Okay, all this is the last part of day 49, the quadratic review. I think it's called the exit ticket. In the first one, select the proper vertex form. We're converting from factored form to vertex form, so we got to find the vertex. And H is right in between the two intercepts. Remember, it's the opposite of what it reads here, so it's -3 and +1. So add those two up, -3 plus 1. Add those up, divide by 2, I get -1. Of course, -1 is right in between -3 and 1. All right, guys, plug -1 back into this to get the K. I end up in -4. And you get that look where it's 2 minus 2. All right, so we can look and see, well, -1, it's got to be +1 here and -4 on the outside. All right. All right, the proper vertex form. Again, this time you're given standard form, go to vertex form. And you got to find the vertex to get it in vertex form. But in this case, you have to find the H. It's not what's in between the intercepts, because you don't know the intercept. You know the formula, -b over 2a. All right, the b is 10, right there, 10. And the a is 1. So 2 times 1 is 2. -10 divided by 2 is 5, or -5. So I'm looking for something that says x plus 5 on the inside square like that. There's right there. All right, but just double check, put the -5 in right there for x there and x there. So -5 squared, then plus 10 times -5 plus 16. Again, you get that look where the 25 and 50, where the second one is twice as big as this one. I got -9, of course, here's my answer then. Guys, again, the axis of symmetry is right in between the two x-intercepts. So the x-intercept is 4 and -6. Add them up, divide by 2. 4 and -6. I'm adding up 4 plus -6. Dividing by 2. And I got -1. Right, that's the axis of symmetry, the x-coordinate of the vertex as well, h. All right? The vertex for some function is 2, -16. So think of it as that the vertex is at 2, down here at -16. One of the x-intercepts is -2. So you can think of it, it comes up here to -2. What's the other x-intercept? It's over here on this side. You can see what it is, guys, all right? This is 4 away, so you go up 4 away from this one. Guys, what's the factored form of this quadratic? Easy. Just look at the intercepts. That one is -3, so it's x plus 3. That one is 2, +2, so it's x minus 2. Again, because in order to make this 0, x has to be 2. That's where x is 2 and y is 0, right there. And that's where x is -3 and y is 0. All right, that's why we do it like that. All right, well, x-intercepts of this quadratic, again, like we found them up here, we got to factor it. It's the factored form. So you're given standard form, factor it. So x minus 8, x plus 5, right? The factor of this. And that equals 0, so x is either 8 or -5. Right there. Be aware, it's not this one. It's not that one. All right? And the x-intercepts of this quadratic right here, when y is 0, and you see all these are 0, you've got to find the x. -5 or 1 to make it 0. -5 or 1. All right? Bing, bing. It's not this one. Greater rate of change. Again, we had this in the warm-up. Exact problem. One of them goes up by 3, and one of them goes up by 4. The one that goes up by 4, I think that's the bottom one. I think it was blue. It's the quadratic. The quadratic goes up by 4. Greater rate of change in the same interval. All right, number 10. Guys, you have to pick linear, quadratic, or exponential. And this is the thing we've been doing the last couple days. Again, this one, they double every time. So the ratio is constant. They're constant. I mean, it's common too, but it's constant ratio. All right, so it's exponential. All right, number 11. Again, guys, obviously this doesn't double every time. Not every time. So, subtract. When I subtracted, like 2 minus 1 was 1. 5 minus 2 was 3. 10 minus 5 was 5. All right, 17 minus 10 is 7. When I subtracted, the first difference looked like that. That didn't help me. But the second difference, of course, is all 2. 3 minus 1, 5 minus 3, 7 minus 5, it's all 2. So the second difference is constant. That's a quadratic, okay? Next one, same thing, guys. And again, just look how far apart they are. I did it kind of the other way here by 3 minus 1, like that. They're 2 apart. And 1 and negative 5, they're 6 apart. You know, 1 minus negative 5 would be 6. Negative 5 minus negative 15, that's 10. All right? But they're 10 apart. Again, the first difference doesn't help, but the second difference does. Again, it's a quadratic. When the second difference is constant, that's a quadratic function. All right, this one, guys, they're all 3 apart. Linear. The first difference is constant. They're all 3 apart. It just goes up by 3 each time. That's linear. And guys, for large values of x, I want you to know this. Exponential takes over and wins the race. Exponential wins the race. All right, for large values of x. All right, that's it, guys. Thanks.